In example 3 from Check Your Understanding, it says, which of the following functions are solutions to the differential equation? We've got a differential equation up here, y double prime plus y is equal to 0. And we're going to choose all that apply. Could be more than one answer here. We've got a little bit of work ahead of us here. We need to figure out what y double prime is. We'll add that to y, and hopefully that's equal to 0. So we'll show you the first one. Now if we look at this, y is equal to e to the x. Y prime is going to be e to the x, and y double prime is going to be also e to the x power. If we look at our differential equation, y double prime is e to the x plus y, which is e to the x, and that's supposed to be equal to 0. Well, that just isn't equal to 0, so this one can't be it. And we'll work with the second one here, part B. So we've got e to the negative x now, and we got y prime then being negative e to the negative x. Remember to use the chain rule here, folks. So when we take the derivative of e to the x, that's negative 1, which is why you see a negative sign out front. Y double prime then is going to be e to the negative x. We still have to use the chain rule here, and the derivative of negative x is still negative 1, but when we multiply that by negative 1, we get a positive 1. If we think about this then, the second derivative is e to the negative x. The original function is e to the negative x, and that's not equal to 0. So B can't be one of the answers here. And we'll move on with y is equal to the sine of x. So y prime will be the cosine of x. Y double prime will be negative sine of x. And we go back to our differential equation. The second derivative is negative sine of x. The original y is the sine of x, so I'll put plus sine of x. And that is actually equal to 0. So this is one of our answers. Remember that the question does say choose all that apply, so it might be one of the other ones as well. We'll just go right down the line here. Here we have y is equal to negative cosine x, so y prime is equal to the sine of x, and then the second derivative will be equal to cosine of x. So here I have my second derivative, which is the cosine of x, plus y, and y was negative cosine of x. That's supposed to be equal to 0, and it is. So D is also another possibility. We just have a few more to do here. I'll take the first derivative of the sine of 3x, which is 3 times the cosine of 3x. Once again, remember to use the chain rule here. The derivative of 3x is 3, which is why you see that there. And then the second derivative, we'll just take the derivative of the first one. So that's going to be negative 9 times the sine of 3x. So the derivative of the cosine is negative sine, which is where the negative sign is coming from. Here's your sine. Keep the inside the same, but then you have to multiply the coefficient here by the derivative of 3x. So that's where the 9 comes from. Then we'll write down our differential equation. Negative 9 times the sine of 3x, that's your second derivative, plus your original function, which is the sine of 3x, is supposed to be 0, but that's not the case. And then for your last one here, we've got part F. So the first derivative of y is equal to 3 to the times the cosine of x is negative 3 times the sine of x. No need to use the chain rule here. That coefficient's out in front, that's fine. And x is just x on the inside of the cosine. The second derivative then will be negative 3 times the cosine of x. So I'll write my second derivative down, and then my original function, and that is equal to 0. So the answers are C, D, and F for this example.